Good evening. I apologize for the unprofessional setup, but I'm using my phone so I can draw, but I don't have any way to hold my phone stationary at home. But I wanted to demonstrate a couple of ways to show kids how to model this particular problem. I think it might be one I saw the other day. And the idea is, ideally kids would see both the linear and the area, but we also want them estimating. And I saw in a classroom someone posted a problem and then had a box at the bottom and said estimates, and I thought that was a great idea. So about how many times would 1/2 go into a little more than 3? And those are good questions to ask, because if a kid can say the answer should be more than 6, I think we're on the right track with that. You could also start with a number line and mark off 3 3/5. So if this is 1, again, I apologize. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So 3 3/5 stops right here. How many 1/2s will go into that? So then you'll have to get the kids to come back and mark off a 1/2, and ideally you would do that in a different color, and I didn't bring a separate pen color. I apologize. So a 1/2 would be halfway in between 0 and 1. And of course I have animals. Halfway in between 0 and 2, halfway between 2 and 3. So how many halves is that? 1, 2, 3, 4, 5, 6, and then some. As a matter of fact, if that's a 1/2, we know it's going to be 7 and then some. So that's not bad for an estimate to see if their answer is going to be reasonable. So I'm expecting an answer probably a little bit more than 7. So to model this, 3 3/5 is 3 wholes and then 3/5 of another. And I'm breaking them all into fifths since that's our fraction. And no, they're not perfect. So that's 3 3/5. One, 2, 3, and 3/5. And we want to divide it by a 1/2. And to be consistent with the multiplication piece, I will ask, this is how I do it, but I'll show you another way too. So 1/2 of this figure is here. So now the question becomes, and you would present this to the students, how many of these pieces will go into these pieces? And honestly, I should have colored that a different color. How many of the pink pieces will go into these yellow pieces? And so hopefully they will say, and it looks orange now, doesn't it? And hopefully they will say, well, it's hard to tell because they're not the same size. And that's exactly right. They're not the same size. How do we make them the same size? It would be nice to make them the same size. So we do that by combining our two drawings. So I'm going to cut all of these in 1/2. And then I'm going to cut this one into 5ths so that they're all the same size. And why do you think I chose to cut them that way? Because it was based on the denominators, how they were already partitioned. So now we're all looking at the same size pieces, which is very helpful. So now the question is, how many orange sets will fit into the yellow set? Pardon me, my dogs are fighting under the table. So how many of these will go into the yellow? 1, 2, 3, 4, 5. Well, there's a set of 5, so that's 1. There's a set of 5, so that's 2. There's a set of 5, so that's 3. There's a set of 5, so that's 4. A set of 5. A set of 5. And then 1, 2, 3, 4, 5, right here. There's my 7. So these will go into here 7 whole times, and I have a remainder. And that remainder is 1 out of the 5 pieces. So my answer is 7 and 1/5. 1 out of the 5 pieces. Does that match with our estimate by looking at the number line? It looks pretty close, because I know I'm not totally accurate when I do this by sight, but I knew it was going to be 7 and something. So 7 and 1/5. So what does this show us? It shows that 3 and 3/5 divided by 1/2. This is 18/5 divided by 1/2. If we were to get common denominators, this would be 36/10 divided by 5/10. And I'm going to stop right here. How many yellows were up here? 10, 20, 30, 31, 32, 33, 34, 35, 36. There are 36/10, and there are 5/10. What that ultimately becomes is 36 divided by 5, which is 7 and 1/5. That helps us, because what the kids would do is 18/5 times 2/1, which is, ta-da. So even though we don't technically use common denominators to divide, we really are using common denominators to divide when we use that rule. It's just that we don't see it because we've learned the rule. But if you show children how one set fits into the other, that rule will begin to make more sense. But what's even nicer is if they ever forget the rule, they can either estimate or make a drawing of their own and go from there.